So we start with the x plus 4 equals 10. We know that 6 plus 4 equals 10. Duh. It doesn't take Einstein to figure that out. But we're solving this, and yesterday we did the mental math part. Now, the mental math part is, we know 6 plus 4 is 10. We got that. Now we're going to enter to the algebraic procedure part. So what's the procedure here? The procedure is, since there is a plus to the variable we're solving for, we actually now have to subtract. The opposite would be subtract. Now, once you subtract it, you're left with a variable, in this case x, and that would give us 10 minus 4, which is 6. So that's the idea behind solving by these inverse operations, as they say. If you look at the next one, y minus 7, and they're asking us to solve this, y minus 7 equals to negative 2, we already know that the answer is what? Mental math, yesterday. Solve this by mental math, what would this be? 5. It's 5, okay. It's 5. Very good. 5 minus 7 is negative 2. Now, mental math, you add 7, okay? And you'd have y equals to negative 2 plus 7 is 5. There you go. So, it is, now you might say, I could just do all of them mentally. Well, that's not the approach. The approach is, you're going to have some with decimals, you're going to have some where you're dividing fractions, and it's not as easy as this. What I'm trying to set in place here is a procedure that will work all the time. The procedure is, whenever you're adding or subtracting something to an x or a y or any variable, you simply use the inverse of that value. For example, if you have, let me give you the next one, x plus 9 equals to negative 5. The opposite would be, since we're adding 9 to the x, the opposite of adding 9 to the x would be subtract 9. Now, we have x equals to negative 5 minus 9, that would be negative 14. Now, what people ask all the time is, do I have to show that if I could do it in my head? Remember, that's not the point in this lesson. I know you could do this in your head. We proved that yesterday in the lesson, that mental math, and certainly that's something we're going to review in this class. But this lesson's actually checking and actually verifying that you know how to solve these algebraically. That's what this lesson's checking, using algebra. Yes, Mr. Edge.
What does inverse mean, like the opposite?
Inverse depends. If you're adding, the inverse would be subtracting. If you're multiplying, the inverse means dividing, or it depends. Like, for example, if you say, what's the multiplicative inverse of 2/3? That would be 3/2. It's the reciprocal.
Okay,
It just depends.
I just wanted to make sure.
Sure. Perfect. Okay. So the next example is u minus 3 equals to 6. U minus 3 equals to 6. Now, if we're subtracting 3, what would be the opposite to subtracting 3? Add 3, and that's what we're checking. But, Mr. Lerma, I know that 9 minus 3 is 6. Do I have to show your work for the 900th time? Yes. The lesson is on inverse operations, not on do it, mental math, all that stuff. And you will have your time to prove that, and that's certainly a very good way to check your answer. But the lesson's actually checking algebraic procedures, not mental math. Is that clear? Let's check the next one. Y plus 25 equals to 16. What's the opposite of adding 25? Excellent. Excellent job.
Yay!
16 minus 25.
Negative 9.
So y is equal to negative 9. If you look at the next one, we have negative 70 equals to x minus 30. And we're asked again to solve algebraically. Now, what some people do is they like rearranging it. I don't know if that's a good idea, but let me show you what the rearranging is. A lot of people like the x to be on the left side, so they simply copy everything the same. The only thing is that they switch the sides. I don't know if that's a good idea. Right. Now, what I will do is, since I'm subtracting 30 from the x, the opposite of subtracting 30 from the x is adding 30, adding 30. Negative 70 plus 30 would be negative 40.
Negative 40.
Now, mentally, of course we could have done that, but once again, we're checking to see if you can apply these algebraic principles. Excuse me. Next example is negative 7 plus x equals to negative 26. I will give you time. Go ahead and try that. I'll give you 30 seconds to try that out.
Oh gosh.
So what do we do? What's the first step? Add 7. Add 7.
Negative 19.
X equals to negative 19.
Yay.
Okay. Any questions?
Sir.
Okay. Now, let's look at the next one. We have negative 15 minus x equals to 22. This is where I'm going to add a little extra. We have to add this little extra step. And we're solving for x, right? Therefore, the first step would actually be to add 15, right? And add 15, add 15. Now this would give us negative x equals to 37, right? Think about it. If negative x equals to 37, what's the value of x? Very good. Very good.
Good job, Pelosi.
Very good. You all understand that?
Yes, sir.
If negative x equals to 37, then x has to be negative 37. Now, if you don't get that, well, let me come down here and give you the algebraic explanation for that. Negative x equals to 37 is the same thing as saying negative 1 times x equals to 37. And since you're saying negative 1 times x equals to 37, that would mean that negative 1 times something would give you 37. The only number possible at this point is negative 37, because negative 1 times negative 37 is positive 37. So in this problem, we did inject a little bit of mental math, and I know there's also a procedure where you divide by the number, and that's certainly fine. I have no problem with that. What I'm trying to show you right now is solve them using adding and subtracting. This problem obviously required a little extra step from you. Yes, sir.
So every time, like in x, if it has a negative sign, x would equal negative 37, or like whatever number.
Right. And look, let me elaborate. That's a good point. Let me give you another example. Negative 21 minus x equals to negative 33. Okay? So, in this step, we would add 21 first. and that gives us negative x equals to negative 33 plus 21 is? Okay. Negative x equals to negative 12. My question is, what's the value of x? Positive 12. Sean?
That thing is awesome.
Okay.
That thing is awesome. That is awesome. Just like Tomas said. Hey, gotta check out my mixtape.
It's on YouTube. It's on YouTube.
People of America, I show you Asian Santa.
No, this is actual Asian.
Okay. I will move on to the next example, which is negative 28 plus x equals negative 3. Okay? Now, how would we solve this?
We're gonna add 28 and add 28.
25.
And x is going to equal to
Positive 25.
positive 25.
Any questions? And let's try this last one that's there, and we're certainly going to do some more. What would we do in this case? So x would equal to negative 9 plus 8, which is negative 1. Sorry. That's a 1. Any questions? Okay. Let me add one new step. I know it's not included in the lesson, but let me preview the next lesson. That way you get an idea of what's really going on here. And should questions like that arise, they're not going to be difficult for you. These are actually called solving one-step equations algebraically. The next part would be something like this. Let's suppose they ask you to solve for x. We have 2x equals to 12. We know the value of x is what? 6, because 2 times 6 is 12. Well, I want you to think of something algebraically. You're multiplying the x by 2. What's the opposite of multiplying by 2? Very good. Very good.
So you're just dividing 12 by 2.
So, divided by 2, divided by 2, x would equal to 12 over 2, which is 6. Now, if we go back to this example over here, which we did earlier, let me pull that example up. We could treat it in the same manner. This example that we did, you could treat it in the same manner. You have negative 1 times x equals to 37. I know for some of you it's basic. However, if you divide both sides by negative 1, same result. X would equal to, what is 37 divided by negative 1? Negative 37, which is the same result.
And it's the same, like multiplication and division are the same, right? Like the negative
What?
and positive.
Right, he means,
That makes no sense.
no, I understand his question. What he means is that if the sign remains the same, for example, it's a very good question. You have negative 3x equals to, let's say, 21. See, on this question, you're actually multiplying by negative 3. So, the opposite of multiplying by negative 3 is dividing by negative 3. Therefore, x would equal to, what's 21 divided by negative 3? That is the correct answer. So, to answer your question, it is correct. The sign carries over. However, if you had a case like this, look, let me do this one right underneath. Negative 3 plus x equals to 21. That's completely different. This one you'd actually have to add 3, and you would have x equals 2, 24. It's a very different type of problem.
I don't know why, like, I just never seen a division with negative numbers, I don't know why.
Just
Well, you